welcome. Happy to have you here for our first ever DoK Ecosystem Day. All right, well, it's hit 10:02. I think we should just kick this off. Hi, my name is Paul. I'm the community manager for the DoK community. Today is our first DoK Ecosystem Day, which is where we're going to start hearing from industry leaders in the DoK landscape, see how they're providing us value to the community members and end users. We want to thank our DoK community sponsors. Our gold community sponsors are Google Cloud and Percona. A couple announcements for some events that are taking place. We have a DoK track at scale, and that's March 14th through the 17th. And then also DoK Day at KubeCon in Paris on March 19th. So I'll be there. Hopefully I'll get to meet all of you as well. If you're interested in getting involved in the community, you can scan this QR code. It'll take you to a place to do that. And then if you're also interested in becoming a sponsor, you can do that as well. Just a few announcements about the format. These are 5-minute lightning talks. We have 8 people. There's going to be a little bit of introduction and in between time. So we're going to limit questions to the chat. So if you put your questions in the chat, we'll then ask our presenters to answer those questions, and then we'll add those to a blog post, their responses, along with the video of this event. So feel free to let the questions flow in the chat, and yeah, we won't have time to get to them during the actual event, but we'll make sure we get those questions answered. And then also, if you want to be connected, I'll show this slide again, to any of these of our presenters, you can fill out this form. You can use that link there. That will give us your information, and we'll connect you with our presenters. And this is not, as it says here, not a sign up for endless emails. It's just a way for us to introduce you to our different presenters. All right, that being said, we have 8 wonderful presenters, and the first of them being Cindy Ho from Dell Technologies. So I'll let her take it away.
Thanks, Paul. Everybody, quickly share.
I'll start your timer right now.
Awesome. Can everyone see?
Yep.
Oh, great. Hey, everybody. I'm a product manager at Dell Technologies. I'm also joined here by Ryan, who some of you may also know, our lead developer advocate, who's on standby for any questions. Get started. So today I'll be talking about how Dell is helping our customers cross the storage chasm with their Kubernetes workloads. This is specific to our Kubernetes data storage software. So Dell primarily works with large-sized enterprises providing services storage for data-intensive workloads, as many of you are aware. Although a majority of these customers are VM-based, Kubernetes is becoming more and more of a priority. There's more exploration in it, which is why we're progressing our data storage software to make our primary storage capabilities more Kubernetes native. And this started with the container storage interface. Dell implemented the universal specification to create our own CSI drivers to allow data persistence with our block and file storage, and more recently our object storage as well. Just a couple of months ago, we introduced the container object storage interface, COSI drivers. So that's been exciting. But with all of this, and from experience talking to customers, these are just table stakes for most of these customers. There are a lot of data management problems that CSI does not currently tackle. So as for our next step, we decided to use these CSI drivers as the foundation to build out more advanced capabilities. And these are called the container storage modules. You can see them as an enhanced layer on top, further accelerating deployment testing for even faster deployment cycles. So today we have 7 of these modules. They have different functionalities on top of the storage arrays. And for some of them, they introduce open source tools and technologies that you guys know very well. Prometheus, Grafana, OpenTelemetry, Rustic, just to name a few. For some others, they take these enterprise class storage capabilities that already exist in the storage arrays and then make them Kubernetes. So Kubernetes native. So we do the reverse there and kind of combine the best of both worlds. For example, our replication module leverages existing replication capabilities of this Dell storage arrays that weren't originally actually designed for Kubernetes. Customers can pick and choose which models they would like to use and for which clusters. And among these, authorization is the most popular. It allows Kubernetes storage admins to apply RBAC rules and instantly and automatically restrict cluster attendance usage of storage resources. That's just a really quick overview. But we've seen that Kubernetes popularity continues to grow. We have more and more customers using these modules. And one question that we've asked ourselves and tried to focus in on is how to make deployment operations of our software even more simple, efficient, and scalable. Many of our customers today are new to Kubernetes, especially in the storage realm. A lot of them, are just exploring right now. And then we also have staff just with a lot of different priorities, like what do they want to use our tool for? So making that entry point to our software as seamless as possible has become a very top priority. And with this, this is why we are introducing a new platform. We are developing a unified user experience and user interface. So it's tying all those pieces together and adding another layer on top, built specifically to simplify multi-cloud, multi-site Kubernetes data storage management. This is called the Apex Navigator for Kubernetes, coming out later this year. It integrates installation and deployment of our Kubernetes data storage software and provides an intuitive GUI that allows staff who aren't Kubernetes experts, not Kubernetes savvy at all, to easily complete jobs without even needing to use command line or having any baseline knowledge. So we're excited for what the software means. This year will be very exciting for us. And we're also, this is just part of our continuation to build our entire portfolio to better enable data on Kubernetes, streamline the experience over and over, add simplicity and performance. So I know that was a lot in a couple of minutes. Thank you all. For any questions, feel free to use the chat. I don't want to take up any more time. Oh, Paul, you're on mute if you're speaking.
Thank you. Yeah, thank you. You came in just under, so great job. Thanks, Cindy. Yeah, again, if you have questions, feel free to add them in the chat and we'll try and get those answered in the blog format. Next up, we have Robert Hodges from Altinity, and yeah, take it away, Robert. Oh, Robert, you were also on mute if you didn't know that.
Tricky. Thank you very much, Paul. I'm here to talk about building real-time analytics with Kubernetes and Altinity. Altinity, that's the company, that's us. I'm the CEO of the company. Let me tell you a little bit about us. So we are database geeks. I've been working on databases for 40 years. We have 45 people in the company worldwide, decades of experience in databases and particularly analytic applications. The folks we typically talk to, and I think a lot of you in the audience, are app developers. You're looking in particular to build analytics, real-time, solve business problems, and you love Kubernetes. So do we. So we do support and services for ClickHouse, a real-time analytic database. I'll be talking about some of the pieces, but the way we got into this was we were developed the operator for ClickHouse that is widely used in thousands of deployments worldwide, and we built an entire cloud on it. Let's talk a little bit about that. I'm going to start with ClickHouse. Excuse me. It is a real-time analytic database. That means it's designed to read vast amounts of data and spit back answers in a second or less. By vast, we mean trillions of data, or trillions of rows of data in many cases. It's kind of like a combination of MySQL, an open source database that runs anywhere, and a traditional data warehouse like Vertica, which is optimized for high performance and reads, and you can read some of the features here. So what can you do with a database like this? Well, It enables you to answer questions on data that is rapidly arriving and where you need to get answers very, very quickly, either because you're giving information to a piece of software, perhaps it's rendering a page and needs to add something to it, or you're an analyst. For example, in financial services, you may be a trader and trying to figure out the best trading strategy to follow. You have an input stream, millions of rows per second of market pricing data. You're iterating through different visualizations or different projections of your asset positions, depending on your trading strategies, looking at things like bid-ask spreads. That's shown graphically and allows you to set your trading strategies. So that's a typical use case for ClickHouse. There are many others. So, let me just hold on this for a second. Where we come into the picture is if you decide that you're going to use ClickHouse, we can help you build the application no matter where it runs. So think of, frame the problem, do the performance analysis, optimize schema. This is support. We do it on any platform that you choose to run on. But what's even better for most people is if we run it for you. And for that, we have a Altinity.cloud, which runs clusters on Kubernetes. For every customer, we spin up a separate environment, one or more. You can run them in our VPCs, so on Amazon, Google, and Azure, or you can run in your own Kubernetes clusters that run in the cloud or even on-prem. We have secure connectivity that allows us to come into any Kubernetes cluster and manage clusters there. And those clusters can then live alongside your applications. What does it look like when you're managing these? Well, it doesn't really matter where you are. We're going to present the same UI, which will allow you to do all the types of operations that you need to do to run high performance analytics. This is just one example where we allow people to scale the clusters dynamically. ClickHouse supports sharding, it supports replication between copies of the shards. We can switch machine types, we can increase storage. All of these things we can do with just a few clicks, and as much as possible, do them while your applications are running. So big thing in this type of system is to be fast, but also to be able to make changes with zero downtime. What's inside Altinity.cloud? Well, we're on Kubernetes. Yep. So was that Paul, what was that symbol?
That was the 1 minute warning.
The 1 minute warning. Okay, thanks. What's inside? A lot of open source software. I won't go into details. You can actually run this yourself. Everything that we build into your stack is open source. And what we do is we help you make it super fast on Kubernetes. So we wire together things like CSI, networking, let you choose instance types. These are just examples of the performance that we get, showing sub-second response on Kubernetes. In fact, we've never seen, over years of using Kubernetes, we've never seen any real performance impact from running on that platform. Instead, it's mostly just big advantages. So if you're doing analytics, building real-time systems, you've picked ClickHouse, come talk to us. We can help you in 3 different ways. We can run it for you on our Altinity.cloud cloud platform. We can help you build the Kubernetes clusters yourself and manage them yourself. And then we can give you software and enterprise support anywhere you choose to run. That's us. So hope to talk to you, and you can ping me on the DoK Slack if you want to talk to me directly. I'm out there and watching for messages. Thank you very much, Paul.
All right. Thanks, Robert. Next up, we have Peter Sherman from Google. So take it away, Peter.
Hey everyone, I'm software engineer at Google, working on storage infrastructure. I'll be talking about the GK Stateful HA Controller, a new tool that can help you balance cost and availability for block storage applications on Kubernetes. So let's talk about availability. I think we can all agree availability can be expensive. And why is that? Data replication. So if you want your data to be available during a zone outage, you need to move your data across zone boundaries at the application layer. All major cloud providers charge for cross-zone egress, and this replication can rack up depending on the data throughput your application handles. The other challenge is extra compute. In order to replicate your data, you need compute running in multiple zones to be able to replicate the data at the application layer. However, for many applications, A single replica properly scaled is potentially capable of handling all your read and writes. In this case, the extra compute capacity is functionally only necessary to provide availability for your data in order to replicate it. What you really want to be paying for is just the storage replication, not the compute required to replicate it. Let's go to the other end of the spectrum, single replica apps that aren't highly available. Kubernetes does have some automated failover capabilities, rescheduling if there's infrastructure failures, but even this has conservative defaults and cluster-wide defaults. Failure detection depends on kubelet reporting unhealthy, your application's tolerance for node unavailability taints, and in the case of block storage, the volume force detach interval. The other challenge is data availability. So in the case of a zone failure, your data may be durable. For example, GCE's persistent disk has 5 nines of durability, but what you really care about is the availability of that data. And in the event that the data is not accessible or services are unavailable in a particular zone, your data is effectively lost for that period of time. So cost and availability are correlated. You can either have low cost, low availability, or high cost, high availability with multiple replicas. Ideally, you'd be in the top left quadrant here, where you'd have low cost, high availability. And the stateful HA controller can deliver a balance of that. If your application architecture can converge to a specific model that maps that domain. For single replica apps, it gives you multi-zone data availability and application-specific rescheduling speed, so you can put an upper bound on how quickly your application can, or on the failover period for your application. And for multi-replica apps, you can achieve a significant reduction in cost by moving to a single zone, but still having data availability in the event of a zone failure. So how does this work? Let's talk about how it's built. It's built on regional persistent disks. So this regional persistent disk is GCP's synchronous zonally replicated block storage product. And the nice thing here is you only pay for the additional storage space. So effectively your storage cost is doubled, but you're not paying the cost of replicating that data. So if you have high cross-network egress traffic, that cost line goes away. The other benefit, or the other building block here, is the stateful HA controller is running in GK's dedicated control plane. It is able to detect node failure. It's able to evict your stateful replicas from a failed node and reschedule your application on an alternate node in the zone. Working alongside the Kubernetes scheduler, it can ensure your application's regional persistent disk back volumes fail over within a bounded period of time to your new node. So you get to control how quickly your application replicas get rescheduled after a node failure. So let's talk about 2 case studies where we can take advantage of this. So first example, Kafka. It's a standard 3 replica application. So 3 zones running in 3 replicas running in 3 zones. It was originally developed by LinkedIn, where cross-zone network was effectively free on-prem if you own the network stack. But Kafka can produce vast amounts of cross-zone network traffic that incurs egress costs. The other challenge is RTO, or I guess the other thing to consider here is RTO. If you move all your nodes to one zone, you get the same RTO if a single node fails. But there is in the event of a zone failure, all your brokers will need to be rescheduled to an alternate zone. So the recovery is kind of a trade-off here. We get quite a significant cost reduction for this pricing model here, 53%. But the worst case failover time does increase. So that is a bit of a trade-off we need to consider. And then the other case study is a standard single replica relational database. You may have multiple reasons to run a single replica database, simplification, cost optimization. But stateful HA can take this existing architecture and give you an upper bound in recovery time, also giving you data durability, cost zone. So if you want to learn a little bit more, we have a blog post out. You can search for GK stateful HA controller. There's a link to the preview there. You can test out and install in your own cluster. And our GA is coming soon in a number of weeks. Thanks all for your time.
All right. Thank you, Peter. Appreciate it. All right. Next up, we have Ian Stedman from NetApp.
Hey, thanks for having me. My name is Dean Stedman. I'm a product manager here on the NetApp team. And for folks that aren't familiar with NetApp, we are a 30-year-old storage company and data services company. We really started our data journey with our customers, really focusing on helping folks manage both structured and unstructured data. And so over the years, we've evolved as the market has, and most recently, being able to offer up our customers our storage services as a first-party service in all three hyperscalers, really allowing customers to build out true multi-cloud hybrid solutions. And then as we look to the future, we're looking at adding in more and more intelligence into the way that folks manage and maintain data. Now, rather than walk through kind of the boring marketing slides that we've got here, I found that for these lightning talks, adding a little bit of humor into it makes this a little bit more memorable for folks. So what I'd like to do is try to introduce three concepts that our team really focuses on when we talk about managing data for Kubernetes. And so to do that, I'm going to, like I said, use a little bit of humor here, use some memes that hopefully will lock into your brain, make you think of NetApp when you run into any of these challenges. So the first theme that we kind of take a look at is making sure that we allow customers to manage applications and data together, and making sure that that linkage between those two is built into everything we do, so that as you're rolling out applications, you automatically know, how they're going to store, how they're going to be backed up, how they're going to be protected, and what their performance attributes are going to be. And the more of that we can bake into everything from the get-go, the easier everyone's life is. So in all of our solutions, we take that application first mindset and make sure that apps and data live together for easy use. Second thing here is that if I've been in the storage industry for 20 years, I can tell you it's not the most exciting thing in the world to manage a bunch of ones and zeros. So the more we can do to help customers to automate their workflows and to build best practices for data management into applications, so that every application is born and deployed automatically with the right performance characteristics, the right amount of capacity, the right replication layers, the right data protection capabilities. The more of that you can inject into the left-hand side of the deployment lifecycle, the happier everyone's going to be. And as an IT guy, quality of life of IT people is something we don't talk about a lot. But getting rid of the boring parts of our jobs and having those automation workflows pays dividends. So keep that in mind. Our third attribute here that we really make sure is that the mere existence of data implies that you're going to need some type of data protection. And whether that's ransomware, or whether that's backups, or whether that's disaster recovery, all of those different use cases have different requirements from a technology standpoint. We offer different solutions at different layers for all of these things, really making it easy for our customers to implement data protection in for their applications at the right level as easy as possible. So if you've got data, protect it. Super simple. Last here is just a little bit of a look at our portfolio. I've kind of called out three different pillars that our team really focuses on. The first is our ONTAP storage operating system. This is an operating system that was born on premises and has now migrated, as I said, as a first-party service to all three hyperscalers. Gives our customers the same capabilities, the same tool sets, all regardless of where they're deploying. We add into that products called Astra and Trident. Trident is our CSI driver set, and then Astra is a data management and data protection platform that we have that augments that, adding in additional capabilities. And then finally, we have a set of solutions from Spot, which are our observability and data management tools, really helping customers focus on right sizing, both from a resource perspective, but then also a cost perspective. And NetApp, we always try to make things super simple to get up and running. We allow customers to start with our Astra product suite. You can manage 10 namespaces for free forever. Super simple to get going with the products. Give it a test drive. And if you have any questions, I'm available in the DoK Slack channel. So nice to meet everyone. Thank you very much.
All right, thanks so much, Dean. Yeah, we're moving well on track, so we may have time for questions at the end, but if we keep moving at the right clip. So next we have Alvaro Hernandez from Congress.
Okay, hello everybody. Let me share my screen here. All right, is the screen okay? I think so. Okay, so I'm gonna talk to you about sharding and sharding on Kubernetes. And I'll just dive in directly. Let me briefly introduce myself first. I am the founder and CEO of a company called Ongress. Ongress is the short for on Postgres. So you can imagine what we do. For people that know me, I'm the Postgres people. If you call me 3 times, I will pop up anywhere you are. So I've been working for Postgres for quite a long time, more than 20 years already. And I like to work on R&D, research and development, trying to come up with stupid ideas. Some of them become something tangible, the software, like for example, Stagres, which is a software I'm going to be slightly talking about today that we have developed as a fully open source project for running Postgres on Kubernetes. I have done a lot of tech talks, around 130, probably close to 140 as of today. They're all online on my website, aht.es, quite short. So if you want to check them out, there's a lot of talks at the DoK also. So feel free to find me over there. And I've also like to do some nonprofits. So I run a Postgres nonprofit foundation. And I've been elected also as an Amazon Hero 2019. But let's talk about sharding today. So very briefly, what is sharding? Sharding or horizontal scaling is basically splitting the workload, the data that I have on a potentially large database into multiple writer instances. Most relational databases, for example, have a typical architecture of a single primary and multiple writers. Sorry, a single writer node and multiple reads. But if you really want to scale this writer node, despite they normally scale very, very well, but if you want to scale this writer node, you need to split the data into multiple chunks and direct each of those chunks to a single writer instance. This is what it means, sharding and horizontal scaling. It allows you to do basically 2 things: to scale the writes, obviously, but also to reduce the blast radius. If one of your writer instances, for example, fails, and even the HA mechanism fails also, or there's some data corruption, it will affect only a percentage of your users. So it's also very good for security and availability purposes. Now, a typical sharding architecture with a relational database like Postgres will look like this. You will have at the bottom all the shards, like where all the data is split into these chunks that will go to a specific server, which potentially will have a replica. So here we have primaries and replicas for high availability purposes. And on top of that, you have coordinators or routing or transaction routers, they're called differently in different technologies, that obviously coordinate the queries, receive the query, serve as the entry point, and then send the queries to the appropriate shard or shards and resolve the queries. They may also be highly available. So this is an architecture that is easy to understand, but if you think about how to deploy this architecture, it's non-trivial. You need to deploy not one server, but n+1. But then if you want high availability with m number of instances, you multiply that. Then you really need to add, typically, at least for Postgres connection, pooling, and specific configurations, and potentially specific extensions, and then functions to build the clusters. And what about distributed backups? So operationally, it becomes very complex. So what we have done at Stagres, thanks by running Kubernetes, thanks by the power of CRDs, is to create a custom CRD that makes deploying this whole architecture with tuning, with high availability, with almost everything that I mentioned here, as simple as typing this YAML. Can you type this YAML? Then you've got to start that cluster immediately. And it's very high level. It just talks about the number of instances, the size, the versions, and that's pretty much it. Then you will get on the web console, if you use Stagres for this, you will get a nice UI where you can see all the status of your coordinators, the shards, and all the characteristics of it. So just to name the features that this supports already is, first of all, is supporting with Citus. Citus is an extension for Postgres, which guess what it does? Sharding. And we just take all the power of Citus and make it extremely easy to orchestrate. It supports both high availability for both coordinators and shards. It does integrated connection pooling, which is very important for Citus. It supports distributed backups, so you get a consistent backup across all your shards. And also, and this is very unique in the industry now, it's not even present on the Azure, at least yet, Heterogeneous shards, that distribution of data may not be homogeneous, and one shard needs to be bigger than the other one. We can achieve this with a YAML file by overriding the specification for a particular shard or shards. And also automated operations for resharding and restarting a cluster. So that's all that I wanted to talk about you today. I'm also available on DoK, Slack, Twitter, LinkedIn, anywhere. Ping me for any questions you may have. Thank you.
All right, thank you, Alvaro. Came in just under 5 minutes. Perfect. All right, next we have Edith Buya from Percona. Take it away.
Yeah, let me share my screen.
Okay.
Okay, is this visible?
Mm-hmm. Good to go.
Just a second, don't put the timer yet. I will set everything good. And okay, I'm ready.
Okay, go for it.
Yeah. Hello, everyone. Thank you for having me. This is Edith Buya. I work in the site of the community at Percona. And today I'm excited to talk about Percona's contributions to the open source community, especially focusing on the data on Kubernetes. But before starting, let's see how this is related with data on Kubernetes and operator SIG. The data on Kubernetes operator SIG discusses gaps in information around Kubernetes operators for the industry and co-creates projects to fill these gaps. Percona is a member of Data on Kubernetes Community. As a database solution company, Percona works with different databases, like MongoDB, PostgreSQL, and MySQL. And when we use databases, we talk about stateful applications that need to keep, save, and secure our data. With Kubernetes, we deployed a database, and it became challenging because we know that Kubernetes was initially designed for stateless applications and not for stateful applications like databases. We call the things gaps with solutions. By extending the API of Kubernetes and developing Kubernetes operators, we were able to fulfill the majority of these gaps. Let's explore some of the use cases. Our operator can create clusters of open source database ready to use. It means that deployment complexity is eliminated, and including these issues such as configuration errors, pods not starting, also nodes that are failing to join into the cluster. With Percona operators, we can automatically scale backups, restore, and upgrade the database. There is no need to worry about storage over-provisioning, networking traffic spikes, applications and services downtimes, or data loss. We can also integrate Percona operator with your existing infrastructure as a code tool, like continuous integration or continuous delivery pipelines, and automate day 1 and day 2 operations in the Kubernetes applications lifecycle. Databases on Kubernetes are commonly considered complex, but with Percona operators, you can simplify database management, enable easy migrations to Kubernetes, and respond to demand spikes in a flexible manner. It also provides a user interface and an API that hides the complexity that Kubernetes brings for the user. We will see that in 1 minute. With Percona operator, we can run databases anywhere, on-premise, on cloud, multi-cloud, hybrid cloud environments, also in thousands of IoT devices. Also, you can move data quickly from one cloud to another cloud without user restrictions or vendor locking. Here are our Percona operators. You can find them all on GitHub. We have Percona XtraDB cluster operator. We have also operators for MongoDB, PostgreSQL, and MySQL. What is next for Percona in the cloud native space? Percona Everest is our next step in cloud native. Everest is an open source solution that enables you to create a private database as a service in your infrastructure. Whether you are a platform engineer, DevOps, specialist, or developer, Everest allows you to deploy and manage database clusters with a friendly user interface, hiding the complexities of Kubernetes, YAMLs, config files, and helps configurations. Everest also utilizes Kubernetes operators to deploy database clusters. You can benefit for functionalities such as scale, storage, restore backup, and advanced monitoring capabilities. What are our unique benefits in our Percona database operators? We are completely open source and free from vendor lock-in. Our operators are supported by Percona and the open source community. And you can find us in our Percona community forum that is always available to help and in our website. Thank you.
All right. Thank you so much, Edith. All right, we have two more speakers. Next up is Matt LeBlanc from Avesha.
Always practice, right? How you doing? My name is Matt LeBlanc. I'm a senior systems engineer here at Avesha. Today, I'm going to talk about KubeSlice and how you can use it to break vendor lock, move your applications to any cloud infrastructure. We're going to be focusing on that one hybrid cloud migration use case, but it does apply to a whole bunch of others, which we're not really going to cover today. One of the big challenges is once you choose a vendor, you're more likely to be stuck in there, whether you're originally a Gmail user and you end up using all of Google's ecosystems, or you started off with an Office 365 license, ended up in Azure, or you just started with AWS. Often customers are stuck in those spaces. And the reason why is once you start there, that data is created, all your applications are designed to be close to the source, making it harder to move. And Avesha makes it easy to break that vendor lock. And we basically use KubeSlice to start moving your workloads to another cloud, somewhere else, any flavor Kubernetes. And here's an example of that. We have this basic application that's running. We have our boutique online web shop. It's the front end, storefront services, right? And then we also have our payment services, the other cloud vendor out there. And you're stuck there, right? You're going to do everything inside of Google. But here's how we break that vendor. Your application connectivity for fleets of clusters without changes to the application. This is a zero trust isolation solution. We're doing that by basically connecting your namespaces. We call that a kube slice, or a slice for short. So how do we do that? Very simple. We're going to create this boutique kube slice, create that slice. We're going to add our clusters to it. In this case, we're going to connect our GKE Google Cloud cluster to our Oracle or OCI cluster. We're going to add that namespace to that slice. And now, once we've created that slice, we've created that secure connection. It is encrypted. We use role-based access control, and you have the ability to really isolate that application isolation information. Now, once you have created that slice, you can then deploy that application over in the Oracle environment, in that new cluster. And once that is up and running, you can retire that old front-end service. Now, the key here is we didn't move the data. We just redeployed parts of those front-end services elsewhere. And it's going to allow you to start a partial migration or hybrid migration where you can start moving. So let's see how that works once we have done that movement here. So first, we'll add a couple items to our cart here. We've got the candle holder, we've got 5 items. And now we have $103 in our shopping cart. We commit that to our purchase, orders complete. And now we can look in the back end, or look at the cluster itself. If you look at that front end, that is now running on that Oracle cluster. And we can check the logs and basically see that same $103.94. Now, just quickly conclude here. You can choose where you want your apps to run. Don't let data gravity drag you down. If you have some use cases where you want to maybe start leaving your original vendor, you want to move to someone else, Avesha is the solution for you. If you have any questions, please feel free to contact me. My email address is matt@avesha.io, where you can scan the QR code down below. Thank you.
All right, thanks, Matt. All right, we are down to our last speaker, which is Rob Reed from Cockroach Labs.
Hello, let me just share my screen with you all.
Great.
Right, thank you very much. I'm Rob Reed, Technical Evangelist at Cockroach Labs, and today I'd like to talk to you about running mission-critical applications in Kubernetes on top of CockroachDB. So it all makes sense to start with distributed SQL. And fundamentally, CockroachDB is a distributed SQL database. That means it brings together a lot of the different database paradigms that we've seen historically. For example, that means the reliability, consistency, and familiarity of databases like Postgres, MySQL, the traditional relational database management systems, the RDBMSs, together with the NoSQL databases, the scalability, flexibility, and resilience of those databases. Historically, those two database paradigms haven't overlapped if we're talking about a Venn diagram, but that's what CockroachDB brings to the table. Cockroach is a distributed relational database, and it provides everything you'd want and expect from that kind of database. It provides referential integrity, normalization, and the like. It also provides serialization by default, so you're guaranteed that whatever you write into the database, all of your consumers of that database will see out. And by adding nodes to it, you horizontally scale, not just for reads, but also for writes. Every node in CockroachDB can handle reads and writes, so scaling is quite a seamless process. And there's no master or primary node in CockroachDB, as you see with a lot of databases. So once scaled, CockroachDB will rebalance the data across the nodes. Essentially, you can think of CockroachDB as being a monolithic key value store, which looks and feels just like Postgres. We chop up the data in each table, and then those chunks are called ranges, and we distribute those ranges to different nodes within the cluster for resilience and scalability. And scaling might be required across regions. In this example, we are scaling across California, Ohio, and North Virginia. You might also need to scale across clouds. CockroachDB has you covered there as well. It doesn't really matter. CockroachDB ultimately boils down to a single binary that we can either host for you in a managed service, or you can run self-hosted yourself. So it also, being a horizontally scalable database with no master nodes, it's really good at surviving multiple kinds of outage scenarios, up to including regional outages and even whole entire cloud outages, if that's your fancy. So, for example, users in this demo, in this slide, they might have been talking to region 3, North Virginia, but let's say that whole region went out, and now we're in the realm of some of the most severe outages in history. The worst you're likely to see in a Cockroach setup, perhaps, is a missing in-flight request that can be retried, but probably more likely, the worst case scenario is you're going to see slightly increased latencies until that region comes back online, and consumers near that region can talk to their closest region. Scaling might also be required across continents. You can harness different database topology patterns in order to get great performance no matter where your users are. So, for example, you can lock data to specific regions, which I'll cover in a minute, by using the regional by row topology. That's great for providing low read and write latencies to users near that region. You can also use the global tables topology pattern, which gives fast, low latency reads to everyone, regardless of where they are. And we've got other products as well. I'm going to talk about serverless at the moment because we run that on Kubernetes. We run dedicated, another offering on Kubernetes as well, but I'll talk about serverless. And it's a great one to try if you're looking at dipping your toes into the world of distributed SQL. So in this example, we see one entry point, a separation of SQL and storage, the isolation between tenant pods, a warm pool of unassigned pods that are ready to be associated to a tenant. And it's also running across multiple AZs, although you're more likely to be running it across multi-region. That's exactly what we tend to do. And let's just focus on tenant 1 for the time being. I see there's a raised hand. Paul, do you have a question?
That was the 1 minute warning.
Oh my word. So what I'll do, I'll blaze through this. So if tenant 1 needs more space, more capacity, we bring in a pod from the hot one. If one that need goes away, we remove it and it goes back into the hot pod pool. If the overnight usage for tenant 1 completely drops off, so do the pods, and it comes back online when they do. So we've got an example of a database running a global application. This took about 10 minutes to create. And I'm running in the UK with low latency and with Great British Pound, GBP. I'm hitting a island database and my application is running in London. If I then hit a German user would experience slightly higher latency. They're still talking to the island database, and they see everything in euros. United States, high latency, but you're not going to talk to a United States database from the UK. So to simulate a United States user, I flick my VPN over and I'm now getting really low latency. And it doesn't matter what language you're talking in. The localization table is completely global. So users, regardless of their language, can get a great experience from the app. And this is the entire database definition for that whole app. I create a database, I enable super regions, and into those super regions, so I'm pinning data to the US and the EU. I create a table called product. And whenever I see a market of Germany or France, I ask for that data to go to the EU Central Frankfurt node. And then the internationalization table is global. And I enable these with just one single line of text. So it's really easy to get a fast user experience and a global database for your users. And we can run on Kubernetes just as easily. That's it. Sorry, I probably went over a little bit there. Your 1 minute warning spooked me, but I'm really glad I got it.
Yeah, I'm sorry. I gave you a little extra there because because of the 1 minute warning spooking.
Thank you.
All right. Well, yeah, thank you everybody for your presentations. These all seem like useful tools. We actually do have a few minutes for questions if people did have questions. I know we heard a lot of information in a very short amount of time. But if people did want to ask questions, we can make a little time for that. Otherwise, I do have a couple more announcements I can make. I guess if anybody has a question, you just raise your hand. We will make this, or this will be available on YouTube. And then we'll also do a follow-up blog post as well. Well, if there aren't any questions, I'm going to share my screen, and you can still ask questions if they come up. Okay, this is basically a slide here. If you want to connect with any of these our speakers, you can scan that QR code, which will take you to a form that just goes to us at the DoK community, and we'll pass your information along if you do want to connect or ask questions to any of the speakers today. Since we have just a little bit of time, I did want to just mention also the new website. So we have relaunched the website. We've tried to make it a resource for the go-to resource for DoK information. So it's a new look, a new feel. We have a new resource library where you can access various resources. And then also we have an events portal where we're going to list all the events, including events like these. And you can access all that information here. We're always also looking for new resources or use cases. So if you have something like that, you can always reach out to me on Slack or LinkedIn, and we can get it added to the site if we think it's something that will be beneficial to the community. Let's see. Okay, well, I think that's it, unless anybody else has anything, any last questions to ask. Okay, well, really appreciate all of your time, both for our speakers and also for our attendees. Hopefully this was useful to you all. And yeah, thanks a lot for attending. And as always, we have these meetings once a month. And this is a little bit of a different format. It's the first of our ecosystem days, but this is normally the time for our town hall event. So yeah, thanks everybody for coming, and I guess you can have a little bit of your day back.
Thanks everyone.
Thanks, Paul.
Bye.
Yeah.
All right. Thank you.
Thank you, everyone.
Thanks.
Bye.
Bye.
Thank you. Bye.